Hello and welcome. Over the next few minutes, I will tell you what exactly happens when you ask ChatGPT a question. How exactly and specifically does it generate an answer for you? So let's dive in and find out. The first thing you have to understand is that ChatGPT is a member of the GPT family. It stands on the shoulders of many illustrious GPT ancestors. In particular, GPT-3 and GPT-3.5 were seminal creations that led to the creation of ChatGPT. And understanding how GPT-3 and 3.5 were built is very useful in understanding how ChatGPT actually works under the hood. So we will start with GPT-3. GPT-3 is a mathematical model, and for those who are technically curious, it's a deep neural network model. So it's a mathematical model, and it was trained on roughly 30 billion sentences extracted from the internet and from various books, and it was trained to do just one thing. It was trained to predict the next word in a sentence given the previous words. So for example, you would give it the phrase, the cat sat on the, and it'll have to predict mat. You will give it elementary my dear, and it has to predict Watson. You get the idea. Now, initially, when you start training GPT-3, it will not do a very good job. So if you give it the cat sat on the, it might come back with a nonsensical next word like spaceship. But over time, as you train it more and more, it gets really good at finding the next most plausible word for the input sentence fragment. Now, once the training on these billions of sentences is complete, GPT-3 can do something very, very useful. You give it any sentence, it'll take that sentence, and then it'll use that sentence to calculate a table. This table has two columns, as you can see. The first column, there is a row in this column for every word in the dictionary. And the second column has a bunch of numbers, and the second column tells you, for every word in the dictionary, roughly what percent of the time does that word appear after the input sentence that you fed GPT-3. So in this example, what we are seeing is that the word mat has a 0.2 or a 20% probability. And what that means is that the phrase, the cat sat on the, was followed by the word mat roughly 20% of the time across all the training data that GPT-3 has seen. Similarly, the word fridge followed the phrase, the cat sat on the, maybe 5% of the time. Now, what can we do with this table? Well, what you can immediately do is, given any input sentence or any part of an input sentence, you can just simply auto-complete the next word using this table. You can do it in many different ways. The first thing you can do, of course, is that you calculate the table, and then you just take the most likely word, which in this example happens to be mat, and you just output that. But you don't have to pick only the most likely word. You can actually sample a word from this table. Because these numbers are probabilities, you can sort of imagine reaching into the table and pulling a word out from this table, and whether you pull out a word or not depends on how probable it is. And that's what I mean by sampling. So clearly, if you do this, words which are very probable, as in this example, mat is 20% likely, and it's the most likely, it's probably going to appear when you do the sampling a lot of the time. But the word fridge is also going to appear some of the time, though not as often as mat. So the key idea here is that words with higher probability will appear more often when you do this sampling. And by the way, this is why when you ask ChatGPT a question, and we'll come back to this later on as well, when you ask ChatGPT a question and you ask the same question maybe a couple of minutes later, it might actually give you different answers. It's because this sampling is going on under the hood, and you need to understand that. Okay, we have seen how GPT-3 can generate the next word given a sentence fragment. Let's see how we can generate paragraphs from this capability. When you ask ChatGPT a question, this question is called a prompt. What it'll do is it'll generate the most likely next word or sample a word from the table, as we have seen. So for instance, if you give it the first 4 letters of the Gettysburg Address, you feed it in, it comes up with the next word. Let's say the next word is ears. And then this is the key trick. It takes this word and then it appends it to the starting sentence. So now the starting sentence has become 7 years. It's fed back into GPT-3, and we get the next word. And then we take this new word that's been generated, append it to the sentence we fed it with, and generate the next word. And we keep on doing this for a while till we reach a stopping condition. So this is how you can generate entire paragraph of text from a very small, simple, innocent-looking starting sentence. In short, repeatedly generate the next word and feed it back in is sort of the key approach that's followed here. Now, why is it called GPT? Well, it stands for Generative Pre-trained Transformer. Generative because, as you saw, it can generate the next word. Pre-trained because of the fact it was trained on all those billions of sentences extracted from the internet and from books. And transformer because the particular deep neural network architecture that it uses under the hood is called the transformer architecture. You might be wondering, well, we started with GPT-3, what about its ancestors, GPT and GPT-2? Well, they were all trained in a very similar predict the next word fashion that we saw GPT-3 being trained on, but there were a few key differences. The first thing was that GPT-3's underlying neural network was much, much bigger. It was a much more complicated mathematical model, and it was also trained on much more data. So those are the key differences. And to the researchers' surprise, when they built GPT-3, it turned out to have unanticipated, or as some call it, emergent capabilities that weren't really foreseen by the folks who built it. Now, particularly of importance here is that GPT and GPT-2 didn't have these capabilities, even though they were trained in much the same fashion. Now, GPT-3 can do lots of very interesting things. You can find numerous examples online, but here are a couple. It is really good at doing continuations of whatever you give it, whatever prompt you give it. So for example, here, you give it a prompt which says The Importance of Being on Twitter by Jerome K. Jerome, London, summer, and a year, and then the word it. So this is the prompt that you feed into GPT-3, and then it comes back with this response. So everything you see below the horizontal line was actually generated by GPT-3. And if you take a moment to read through this thing, you will realize that it's actually very coherent text, as if a human wrote it, as if Jerome K. Jerome wrote it. So it's really good at doing these continuations. And in particular, GPT and GPT-2 were not as good at doing this. But it can do other very interesting things as well. So what you can do is you can actually list a few examples in the prompt itself, and it'll actually learn to sort of auto-complete the examples or auto-complete the pattern that you've specified in the prompt. So what you will see here is a prompt where we have pairs of sentences, English sentences. There is a poorly written English sentence followed by a well-written English sentence, poorly written, well-written, and so on and so forth. So for example, the very first pair that you see is the poor sentence is, I eated the purple berries, and the fixed correct sentence is, I ate the purple berries. And similarly for the other two examples. So you give it these three examples, and then you end with just a poor English input. And you can see what it is. And you feed this prompt into GPT-3. It has sort of realized, it has sensed the poor, good, poor, good, poor, good pattern here. And it sort of almost cannot help but auto-complete the good English version of the poor English input you just fed it. That's what it does. And strikingly, you will notice that it has learned to fix the error. So this is an example of something that is an unanticipated ability, and the researchers did not expect it was able to do this, but it can. Now, all this said, it was not very good at following user instructions. So for instance, let's say that you make this request to GPT-3, help me write a short note to introduce myself to my neighbor. What does it come back with? It will come back with something like this. What is a good introduction to a resume? Good introduction to a resume. Best photos of resume introductions. This doesn't make any sense. It's nonsensical. It does not actually respond to the specific instruction. It is doing some strange autocomplete based on their input sentence. Now, why does this happen? Well, apart from, figuring out why it happens, let's just also spend a moment to say that apart from, output that's not very helpful or relevant to your particular instruction, it may also give you factually incorrect output or offensive output, and there are numerous documented examples you can find online. So let's go back to why it produces unhelpful answers. Well, the first thing we have to recall is that it was not explicitly trained to generate good answers to user instructions. It was only trained to guess the next word. So perhaps it's not all that surprising that it can't follow instructions. So how can we fix this? Well, let's explicitly train it to follow instructions. And that's in fact exactly what OpenAI did. They developed an approach to exactly this, and we'll look at this next. Now, the approach that OpenAI created to make GPT-3 follow instructions led to GPT-3.5, and we'll double click on this exact process in the slides to come. The first step of this, it was a three-step process. The first step was we will get humans to write high-quality answers to instructions. So OpenAI gathered about 12,500 instruction answer pairs. So here's an example. You can ask GPT-3, explain the moon landing to a 6-year-old in a few sentences. And GPT-3's answer is, explain the theory of gravity to a 6-year-old. I think you will agree that it actually does not answer the question. It just comes up with another instruction, which doesn't make sense. And then the human-created answer for the same instruction is, people went to the moon in a big rocket, walked around, and so on and so forth. So you'll agree with me that the human-created answer actually tries to answer the instruction as opposed to GPT-3's answer. So they created 12,500 such instruction and high-quality answers. And once they did that, they used this data as training data to train GPT-3 some more. And for the technically curious, it's a process called fine-tuning, and they used a technique called supervised learning to do this. Once this was complete, this step was very helpful. Supervised fine-tuning is what this process is called, and the supervised fine-tuned GPT-3 did much better on instructions. In fact, we would love to do much more of this supervised fine-tuning if we can. But there's a small problem. Writing high-quality answers to thousands of instructions is difficult, labor-intensive, and very expensive. Is there an easier way? Well, what is easier than writing a good answer to a question? I think we can all agree that it's much easier to be a critic than a creator. So in that vein, what we can do is, for a particular question, if we get a set of different answers from an outside source, it's quite easy for us humans to rank the answers from sort of most helpful to least helpful, right? So this observation sort of sparks an approach, which is, we can feed a question to GPT-3, and we can have it generate multiple answers to this single question. And recall, because of the way the sampling works from the table we saw earlier, getting GPT-3 to generate multiple answers to the question is actually not that hard at all. It's pretty easy because of sampling. You sort of get it for free. So we can generate multiple answers to this question, and we will simply provide the question and these answers to humans and ask them to rank them from most useful to least useful. Note that GPT-3 may actually not come up with great answers to these questions at all, but that's okay, because we only want the ranking from most to least useful. So this was step 2. OpenAI collected 33,000 such instructions, fed them to GPT-3, generated multiple answers to each of those instructions, and then had a team of humans rank them from most helpful to least helpful. And using this data, something called a reward model was built, again using this technique called supervised learning. And this reward model can do something very, very useful. If you give it an instruction and an answer, so I'm giving the explain the moon landing instruction along with GPT-3's original, terrible answer, which is explain the theory of gravity. If you give an instruction and answer to this reward model, it can actually give you a numerical rating, a number which indicates how good that answer is to that particular instruction. So in this case, obviously, it's a terrible answer. So it's giving it, let's say, a 0.02. On a scale of 0 to 1, maybe it says 0.02, which is pretty bad. Now, if you give it a much better answer, perhaps a human-generated answer, right, like the example we saw earlier, clearly it's a wonderful answer. So the reward will come back and say, give you a much higher number, let's say 0.95, right, which is much better. So this is the key thing that the reward model can do. Give it a question and a potential answer, it'll come back and give you a number which indicates how good the answer is. So we can use this capability to improve GPT-3 even further. So what we do is we send an instruction to GPT-3, we get an answer out, and this answer may or may not be good, we don't care. And then we feed both the instruction and GPT-3's answer to the reward model, which in turn gives you a number, right? A rating of how good that answer is for that particular instruction. And now this is the key step. We take this number and then we use this number to nudge GPT-3 in the right direction. And we do it for thousands of questions. In fact, OpenAI used 31,000 questions for this step. And this process by which we are nudging GPT-3 in the right direction using the output of the reward model is called reinforcement learning. It uses a technique from the field of reinforcement learning. So to summarize, this 3-step process is how GPT-3 became GPT-3.5. Write human question-answer pairs written by humans, fine-tune GPT-3, have GPT-3 provide multiple answers to the same question, have humans rank the answers, not write them, but just rank them, build a reward model with this data, and then use the rating from the reward model and reinforcement learning to fine-tune GPT-3 even further. Now, by the way, you will hear the phrase reinforcement learning from human feedback pretty often in the field, and now you know why we call it that. From human feedback, because we will have humans rank the answers to help us build this reward model, and reinforcement learning because the nudging we talked about earlier is done using reinforcement learning. Okay, so by the way, when you're working with ChatGPT, and you may have done this yourself, you see this little thumbs up, thumbs down sign, which you can click on to indicate how well the answer from ChatGPT answers your question. You're providing training data for this process, just so you know. Okay, now let's see how GPT 3.5 does on the original prompt that we use, which is help me write a short note to introduce myself to my neighbor. Hello neighbor, my name is so-and-so, I recently moved, blah, 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 blah. Wonderful. It's a really good response. And you'll agree with me that it's just vastly, vastly better than what GPT-3 could produce. So now that brings us to the final leg of our journey, which is how do we go from 3.5 to ChatGPT? Well, the process that was followed by OpenAI was actually very, very similar to the three-step process we followed to go from 3 to 3.5, but with one key difference. And that was, instead of just using instruction-answer pairs or question-answer pairs, they used entire conversations as the training data. And this makes sense because if you want to build a conversational bot, i.e. a chat bot, you have to use conversations. That's sort of the raw training data that's needed for that. And so that's what they used. But apart from that, apart from the fact that they used a conversation data set, the process was more or less the same. First, there was supervised fine-tuning, then there was a reward model, and then there was reinforcement learning. And that's how ChatGPT came into being. Now, how well does ChatGPT do on an original prompt? It actually seems to do an even better job, as you can see, compared to even GPT 3.5. But, there is more, because ChatGPT was trained on conversations, you will recall, not just question-answer pairs. So what that means is that we can ask follow-on questions to whatever questions we post, and you would have already seen it from your experience, playing with ChatGPT. So you can say, can you make this, response a bit more formal or a little less formal? And of course, it'll oblige. It'll do the right thing for you. And so that is ChatGPT and how it is built. Now, sort of a note of caution here, while ChatGPT is much better than its predecessors in many ways, it's still prone to many of the same shortcomings in terms of, giving responses that may be harmful, that may not be helpful, that may be offensive, and so on and so forth. So you need to be very, very careful. Now, the journey continues. We have seen GPT-4 come out after ChatGPT. There are ChatGPT plugins. There are custom instructions. The list goes on. There is never a dull moment in this space. So when you see ChatGPT do amazing things, write poetry, write essays, explain jokes, solve reasoning problems, write Seinfeld episodes, write code, and so on and so forth, remember this. This loop of take the starting question, generate the probability table, pick a word or sample a word from the table, append it to the starting question, and do this thing again. This whole loop may run tens, hundreds, thousands of times before the answer gets generated for you. So this is really what's going on under the hood. In the interest of time, we could only sort of scratch the surface of this very exciting topic. If you're curious, I invite you to explore the other resources in the Sloan AI Hub, and you will find that there's a lot more interesting things that are going on in this very exciting space. Thank you for watching. I'm Rama Ramakrishnan.